This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. So friends, in previous session we have started our third module, that is very important module, that is nothing but PySpark. So in today's world, what we are willing to have, we want to process our data with low latency. Okay, whatever we are going to process, if it is taking too much time, it is if it is having certain issues with respect to timings and all, then we want to optimize it, or we want to have a framework which is able to provide the data or result within small duration, or sometimes like we want to have outcome in real time. So Hadoop was having certain issues, like it was having the latency related challenges, and because of that, like people were looking for a solution. Researchers were looking for a solution, and then Spark came into the picture. And what I have mentioned in previous session, that it is providing four different APIs. If the person is having the knowledge of any of the programming language, Python, Java, Scala, and R, then he or she will be able to take the benefit of Spark distributed computing. Okay, so what exactly the Spark is? Uh-huh. Module is PySpark, a Session-2. Okay, so what is PySpark? Can someone explain what is PySpark?
Python plus Spark.
that is that is fine, Python plus Spark. What else? Why we need to
This
have this?
is big data processing engine we use in
Hmm.
space of MapReduce to reduce the latency, because if the disk-syncing operation is not there, we are here using memory operations.
Mm-hmm.
So this is better in latency. So this is also very flexible because we can choose storage at our choice, and we can choose uh, cluster manager of our choice. Uh, uh, in spite of MapReduce, it is limitation. We can use only SDFS as a storage, and uh, Yarn as a cluster manager only. So here there is no limitations of storage and cluster manager. So
Hmm.
it's better
Okay.
in terms of latency, and we have it is better than MapReduce.
Hmm. Fine. Perfect. So uh, let me try to reframe whatever you have mentioned. So PySpark is nothing. It is lightning fast, general purpose, distributed. I can say distributed. It is lightning fast, distributed, general purpose, in memory compute engine. Okay. So you have mentioned that it is able to provide the result or insight from the data with low latency, or latency is improved over here. So that is nothing but it is covered with the help of lightning fast. It is able to compute the data at a highest speed, and you will be able to get the result in shorter duration if you are going to compare it with Hadoop and other processing mechanism. Distributed compute distributed. What is the meaning of distributed over here? Over here, like as what we have seen in Hadoop, so that is master and slave architecture. Distributed is nothing but once we are having bunch of machines. Okay, over here as well, we are going to leverage that programming methodology or that cluster computing framework. One is master, one node is master, and other nodes will be acting as a slave machines, which are utilized in order to process the data. Okay, so distributed, that is nothing but like bunch of machines are required or utilized in order to process our data. General purpose, so with the help of general purpose we are able to see that inside the Hadoop, in order to perform 100 of the things, we need to learn 100 of the programming methodology. But with PySpark or Spark, we just need to learn one way of coding, one coding methodology, and then we will be able to perform 100 of the things in memory. So computation inside this Spark are performed inside the memory. So all the computations that you are going to perform are performed inside the memory. And compute engine, definitely like it's a compute engine. We have seen like in Hadoop, if we are going to replace MapReduce with Spark, then we will be able to take the benefit of Spark distributed computing, and it is able to process the data within shorter duration. Okay, so that's why like I have mentioned compute engine as well. So it is lightning fast distributed general purpose in memory compute engine. Once we are going to perform the processing with the help of Spark, then what I have mentioned, we just need to opt up programming API. Okay, and we need to proceed. Uh, so if we want to work with PySpark, then there are different, you can say, flavors. Flavors with respect to the flavor of data. If we are having batch processing, then we are going to utilize certain other components in order to process. If we are having the streaming data, then we are going to utilize other components. So let me mention. So we are having two types of data: batch data and streaming data. Okay, what is batch data? Batch data,
It is history data, sir.
Store data,
History.
data
mm-hmm.
not change with respect to time.
It's a history data, stored data.
Non-transactional data.
We can say all of you are correct. So say you can take it in this way, like you are having certain RNCs, and you are having certain raw reports with respect to each and every RNC, and for each and every hour the report is captured, the row counters are captured and dumped into a particular location with respect to that particular RNC. Let me mention over here. So say row reports are there, row reports, and we are having one RNC. So in this particular RNC, say we are having the data for say 1100 hours. Okay, then we are having the data for 1200 hours. Okay, okay, then 1300 hours. Okay, so you can take it in this particular way, like you are having row counters which are generated, uh, or what I can say, inside the Ericsson. If I'm going to take an example of Ericsson, you are having ANIC over there or OSS. Okay, so what that particular OSS or ANIC is going to perform, that is going to capture the row counters. Okay, and based upon the configuration that you have set at the anic level. So it might be, say you want to process the row counters at every 15 minute. So you will be getting the reports inside the RNC at every 15 minute. Okay, so because like we are processing the row counters at any level at 15 minute or hourly level, inside the RNC we are getting the same, you can say, reports. Now we have kept these particular reports, okay, raw reports or row counter reports inside a particular location named as RNC. It might be stored in say S3 location. So what will happen over here? Say if I want to process these particular reports, okay, if I am going to process these particular raw reports in order to generate the KPIs. So at hourly level, say at 1100 hours, okay, or say 11:15, I'm having the 1100-hour reports. So I will run a job that is nothing but batch job. Just try to focus over here what is happening in the processing, data processing domain. Okay, so what I can do, I know that for 1100 hours I will be getting the report inside this particular location. So what this particular batch job will do at 11:15, say I'm thinking that by 11:15 I will be having this particular report in this particular location. So this batch job, what it will do, it will pick this particular report from this location, process it, and then it provide me the outcome in terms of KPIs. Probably at this moment you will be able to recall, say uh, it is assumed once, like I was there in Ericsson. So it was assumed that for say 1100 hours the raw counters will be generated by 11:30, and by 11:40 I will be having the KPIs. So if I need to have 1100 KPIs, then I'm going to check the time. So say it's less than 11:40, then I will say like the report is not available at this moment. You need to wait for some time. Are you able to recall? All of you, are you able to recall?
Yes, yes, Ashok.
Okay,
Yes, Ashok.
so this is what this is what with respect to like the reports. So raw reports, that is nothing but the batch reports. Like these are generated in batch and processed in batch as well. Okay, and then we are getting the outcome. So with respect to the data, we are having batch processing and streaming processing. Batch processing and streaming processing. So Spark is going to handle both batch processing and streaming processing. It is over here. It is not going to have the linkage with respect to the previous outcome. So let me take an example. So what is happening in the streaming field? Say I'm going to perform the running total. Running total. Just pay attention over here, running total. So the data is being generated, say 1 2 3 3 4 5, as in this particular way the data is being generated. Okay, now if I want to have the sum of the numbers, so say the customer has given one number, so it will be taken, then after then in the next second it has given say 6. Okay, then on the next instant it has given say 2. Okay, so what I'm going to perform over here, I'm going to store this particular history. Say 3 plus 6 is 9, then I need to keep 9, and 9 plus 2, then it will be 11. So I'm going to keep the history, but over here there is no need to keep the history what has been processed in previous execution. So say first I have processed this, like this is the single record, then new record came, and 3 is the previous output, so 6 plus 3. So my outcome is dependent onto the historical values. So and once I'm going to perform the streaming data processing, then like it might be possible we need to maintain the history, and the processing is happening in near real time. So we are going to, although over here we are going to take the data in batches, but these particular batches duration is very less. Okay, and we are going to process it. So it is said that Spark or PySpark is near real time processing system, near real time. We are taking the small batches of shorter duration, and then we are going to process. So say this is the first batch, this is the second batch, this is the third batch, this is the fourth batch. Like we are taking this data, processing it, storing the output, and then moving on to the next batch. So historical, like it might be possible we need to maintain the history, and the batch duration is very small over here, and Spark is near real time processing system. Okay, so we are having two types of processing: batch processing and streaming data processing. So with respect to batch and streaming, what we are having certain components, some RDDs, data frames. Okay, data frames. Now, once we are talking about RDDs, say batch processing and streaming data processing. Okay, batch processing and streaming data processing. Now, once we are having batch data, then we can process it with the help of data frame or RDDs and Spark SQL. Spark SQL. Okay, so we can utilize any of the API in order to. This is nothing but like lower level construct. RDD is lower level construct, and data frame and Spark SQL, that is nothing but higher order construct. The Spark, this particular you can say keyword, lower level construct and higher order construct, and we will be having discussion on that. So RDDs. Now with respect to batch processing, once we are having data that is coming in batches, and we need to get those particular batches and process and provide the outcome, then we are having three component. Okay, uh, data frames, RDDs, and Spark SQL. With the help of this, like we are going to process that particular data. Okay, now what I can say, just a minute. Okay, so RDDs, data frames, and Spark SQL. Now RDDs, RDDs, that is nothing but resilient distributed data set. Data set. Okay, once we are going to perform the operation is nothing but processing with the help of PySpark. So we can write our code in terms of with the help of RDDs, with the help of data frames, with the help of Spark SQL, and we will be able to solve our problems. We will be able to write down the code with respect to a particular application or use case. RDDs, that is nothing but lower level construct, what I have mentioned, lower level construct. So RDDs, let me show you one diagram. Hmm. Okay, let me take this one. Okay, so over here, just have a look. What we are having, we are having Spark core. Spark core. So inside the Spark core, we are having RDDs, and the data processing is done with the help of RDDs only. So if you are using RDDs, that is nothing but lower level construct, and it is executed onto the Spark core, or onto the Spark core. In another words, what I can say, we are going to write down the code in lower level constructs, that is nothing but RDDs, and which are executed and with the help of Spark engine. Okay, you can think in this particular way. You can say it in this particular way. Spark core is going to understand RDDs, and it is very near to, you can say, Spark core, and then execution is being happened, and we will be able to get the outcome up. However, once you are going to write down the code with the help of data frames and Spark SQL, okay, Spark is going to take that and it is going to convert it into RDDs. We will be going to learn tungsten engine and all, where we will able to see that these particular data frames and Spark SQL is converted into the RDDs, and then it is executed and we are able to get the final output. Let me show you that particular diagram as well. Tungsten engine and Spark. Okay. Just have a look over here. What we are able to see, we are having SQL query and we are having data frames. Now you have written your code over here, and at the end, like, it is converted into RDs in order to have the execution now. Okay, just like focus on to the start and end. Rest of the things we will be covering in our upcoming sessions, no need to worry. Like, once we are going to discuss the tungsten engine, then we are going to cover this. Okay, however, like, I can explain at this moment, but it will be a heavy dose for you. You will not be able to understand what is happening inside this. Okay, so data frames and SQL query is converted into RDDs. That's why, like, we are saying RDDs are lower level construct, and data frames and Spark SQL, these are the higher order construct, and with the help of tungsten engine, these are converted into RDDs in order to have the execution. Okay, so batch processing is done with the help of RDDs and data frames or Spark SQL. Another main thing with respect to RDDs, it is schemaless. It is, or these are schemaless objects. Okay, so schemaless objects means we are not having the column related information. So we are going to process our data, and like this particular coding methodology or RDDs are not going to maintain a particular schema. Okay, but once we are going to have data frame, what is a data frame? Once we impose a schema onto the RDD, then it will become a data frame. Imposing schema on RDDs. Okay, so that is nothing but a data frame, higher order construct, and utilized for the batch processing. A lot of differences are there, but on to the higher side or on to the from the top level, what I'm going to explain the basics only, because we have started Spark at this moment. Like these are the initial days of Spark. A lot of differences are there, but we will be going to cover those particular things in our upcoming sessions. So batch processing is done with the help of RDDs, data frames, Spark SQL, dealing with say, structured data. Okay, so structured data means like over here we have imposed a schema. So previously no schema was maintained once we are working with RDDs, but schema is mandatory once we are working onto the structured data or semi-structured data. Then like on RDDs we need to impose a structure, and then it will become a data frame. So whatever is available, whatever we have explained with respect to data frame, that is replicated to Spark SQL as well, and SQL like queries are utilized in order to process the data. Okay, so that is nothing but Spark SQL. So batch processing is done with the help of these components, and now if we are coming with respect to the streaming data processing, then it can be done with RDDs. Okay, and it can be done with data frames or Spark SQL. Like both of these components, the three components, can be utilized for batch processing and streaming data processing. So once we are using RDDs in order to process streaming data, that is nothing but Spark streaming. That is known as Spark streaming. Let me mention Spark streaming. Spark streaming. Once we leverage RDs for processing of streaming data and Spark structure streaming. Spark structure streaming. Once we leverage data frames or Spark SQL for processing of streaming data. Let me show you something. Apache Spark. This is the official website for Spark, and once we are going to the documentation, so inside the documentation what we are able to see: Scala, Java, Python, R, SQL, that is built in functions. So it is having 4 APIs: Scala, Java, Python and R. Then programming guidelines. Okay, so first what we are able to see: RDDs, accumulator and broadcast variable. So this is with respect to the lower level API or lower level constructor. Then SQL, data frames and dataset. Datasets are not available in Python. Datasets are available in Scala. So we will not be going to have the discussion onto the datasets. So SQL and data frame, that we have seen. Structured streaming, that is nothing but once we are going to leverage SQL or data frames for processing the streaming data, and Spark streaming, once we are going to utilize RDDs for processing the streaming data. Spark streaming, that is known as dstream as well. Okay, mlib, that is machine learning, GraphX, Spark or PySpark. So PySpark we are going to learn, but these are the you can say add-on stuff like mlib, GraphX for Spark R. Once you are going to write down the code, then you are having documentation for R. If you are going to leverage Python or PySpark for writing the code, then you are having the documentation for PySpark. So on to the top, like RDDs, SQL data frames and data sets, structure streaming and Spark streaming. This is what I have explained over here. Like what are the different flavor of Spark? So Spark can be utilized for processing the batch data and for stream and processing the streaming data. Once we are going to leverage Spark in order to process batch data, then we are having RDDs, data frames and Spark SQL. Data frames and Spark SQL, that is higher order construct, and these are having certain optimization. Okay, we can have certain optimization onto top of this inbuilt optimization, what I can say, and these are the most preferred, you can say, components in order to write down the code. Data frames or Spark SQL. RDs are the lower level construct, and like there are certain benefits as well in order to use RDDs, but these are not preferred because they are not having a valid schema. And if we are talking about data frame and Spark SQL, they are dealing with the valid schema, and we are having a valid schema, and it is very easy to work with the data which is having a valid schema or a structure. So once we impose a structure on RDD, then it will become data frames or what I can say Spark SQL. Spark SQL is also having structured data with in a row and table, a row and column format or tabular structure is there, and it is best for processing the tabular data. Okay, like we are going to process the data in terms of a SQL table, we will be going to write down the SQL commands for getting the outcome in order to have the analysis on top of our data. Once we are having streaming data, then also we can leverage RDDs and data frames or Spark SQL, but at this moment we are having different methodology. Okay, pronunciation, or you can say a naming convention for streaming data is different. Once we are processing the streaming data with RDDs, that is known as Spark streaming. And once we impose the structure on RDDs, that is nothing but data frames. So Spark structure, like imposing a structure on RDDs or imposing a structure on Spark streaming, that is Spark structure streaming. A valid structure is there, it means a valid schema is there. If valid schema is there, that means we are processing with the help of data frames and Spark SQL. Okay, so this is like why I have explained this, because like we have started our journey, and there are different ways or different types of data, different flavor of data is available, and based upon the flavor of data you need to opt a module. Okay, it might be batch processing, or like you can proceed it with RDDs or data frames or Spark SQL, or you are having the streaming data, then you can proceed with Spark streaming or Spark structure streaming. If you are having a valid schema, then Spark structure streaming is there. If you are not having a valid schema, then you can process it with the help of RDs. Okay, so based upon the flavor of data, the nature of application, we are having different, you can say, components and different actions and transformations inside the Spark. We will be discussing about actions and transformations with respect to the component that we are going to pick in order to solve our problem. Now, let me pick RDD. RDD. Okay, we have talked about this, like RDDs are nothing but resilient distributed data set. Resilient distributed data set. So can someone tell me what is an RDD? What is a RDD? Naresh, what is
Yes,
RDD?
sir. Sir, actually, it's a fault tolerance, lazy evaluation, caching, and in-memory computation.
That is the
All of these.
property of, those are
Yeah.
the features or properties of RDDs.
Yes, yes.
But what is RDD?
In data structure,
We can say data structure, but how it is different with another data structures?
doesn't have any
It's a
schema.
non-structured data set.
Unstructured data.
Yes, yes. Unstructured data as well as low-level.
Low level
Doesn't have
construct.
any schema.
Yes.
Mm-hmm. Okay, these are the lower level construct. That is fine. That is perfectly fine. And uh, over here we are not having a valid schema. That is also fine now. But once we are talking about RDs, then there is certain other stuff. This is in memory distributed collection of element. Collection of elements. Okay. In memory distributed collection of elements, what is the meaning of this? Like whatever we have mentioned over here, these are the properties. It is say lower level, it is of lower level construct type. Okay, schema is not there. Schema less object. Okay, so it is in memory distributed collection of element. Now what is happening in the Spark world? We are having master and slave structure. Master, and we are having slave machines. Slave 1, slave 2, slave 3, slave 4. Okay, okay. The master over here is known as driver. Driver, and the slave machines are known as the worker node. Worker, worker. Okay, worker. Okay. So if I am going to have a particular say list, and that is having certain elements, say 1 2 3 4 5 6 7 8 9. Okay, so now what is the meaning of this? Like I'm having a list, and this particular list will be will be available on a particular machine only. Like if I'm having, this is the monolithic way of computing, what I can say. If I'm going to declare something as a list, then it will be available on a single machine only. Okay, it will not be able to have the benefit of distributed computing. Okay, if the data is placed over here only, then how these particular machines or slave machines or worker nodes will be utilized in order to process. So what will happen if we are going to create a RDD on top of this particular data, then it will be distributed to this particular cluster. Okay, and how we can do this? So sc dot parallelize, and we can pass this particular data. Okay, say RDD1 now. Okay, RDD1. Okay. Okay, so now what will happen? This particular RD will be distributed among these particular machines. And if this particular RD is distributed among these particular nodes, then it will be available on each and every machine. Okay, and once it is the time of processing, all of these particular slave machines are utilized in order to process this particular data. But how we are going to decide that it will be able to be distributed onto these particular machine? Okay, so we are having certain parameters we will be discussing, like default parallelism. Default parallelism. Default parallelism. So this particular parameter is going to decide that say if default parallelism equal to say 4, then we will be having say 4 chunks of this particular RD. It might be say 1, 2 over here, 4, 5 over here, 6, 7, and 8, 9. So 1, 2 will be available over here, 2, 4, 5 will be available over here, 6, 7, and 8, 9 over here. So default parallelism is the parameter which is going to decide like how many partitions, what I can say at this moment, or how many chunks of this particular RDD will be there, and then it will be distributed. So in memory distributed collection of elements, so it will be available in different machines, and then processing will be done and we will be able to get the outcome. Okay, RDD is nothing but distributed collection of element. Now ways to create RDDs. Create RDDs. Okay, ways to create RDDs. So first of all, like once we are going to read the data, once we read the data, then it will create a RDD. Okay, while reading the data. Okay, so once we are going to read the data, then it is going to create a RDD. Okay, so this is the method one. Let me try to show you something. So okay, so I have shared one link of YouTube PySpark installation, environment setting and installation, Spark installation videos. Okay, and what I assume you need to proceed with that particular link, and you need to have the Spark in your machines. Those are straightforward steps that you need to take. I will share the presentation and the word file as well, which is having those particular steps, and then you will be able to have the Spark in your machines. Okay, so once you are having Spark in your machine, then you will be able to do the coding, do the practice onto the Spark. So we are having virtual machine, and in virtual machine we are having Hadoop, but we are not going to leverage the Hadoop Cloudera Quick Start VM. At this moment, we are going to install the PySpark or Spark on our local machines or Windows machines, and on Windows machines, we will write down on Windows machine itself. We are going to write down our code, and that will be good for the learning perspective. So I will uh, give you the inputs about the Databricks and EMR as well, like how the EMR cluster is being uh, started, and how you will be able to write down and execute your code. That we are going to learn, but at this moment try to proceed with that particular recording, and have Spark in your machines. Okay, so what I have mentioned already, that is nothing in memory distributed collection of element, and how you will be able to create the RD while reading the data. Okay, let me try to have uh, hmm, and let me start PySpark over here. Because have you installed PySpark? Is it working for you?
Uh, Almost I installed, but the last I stuck in the pie chart.
Okay. Is this
Yeah,
particular screen coming up?
yeah, screen is coming, but
Okay.
I need to set some setting. So do some set. So just waiting for the
Hmm.
presentation. So the
Okay, I will
PPT
share
will.
that presentation. I will share
So
that presentation. I got your message, but I forgot to share.
yeah,
No need to worry.
actually I try to install in my personal laptop, but going to.
Yeah, yeah, yeah. That is fine. You need to install in your personal machine only. Okay. So what we are able to see, once we have typed PySpark, and let me try to share the open the presentation.
And Ashok, one more thing. If
Mm-hmm.
possible, can you share today the solution of the assignment one, the one you shared na, to us?
Oh,
If you
okay,
have,
okay, okay. Yeah,
I
yeah,
think
yeah.
yeah, please.
Mm-hmm. Mm, I think it will be okay. Python environment setup. Okay. So let me explain what you need to do in order to setting up the Spark environment on the Windows machine that we are going to leverage in our learning journey. And we will be going to write down our code uh, in PyCharm IDE or onto the Spark shell for the learning perspective. So what you need to do, you need to have this much of configuration in your machine in order to install the PySpark, okay, or Spark in your machines. Then there are certain steps like you need to install the Java, then you need to install the Python, okay, then you need to download Spark and download WinUtils files and download and install PyCharm IDE. So these are the steps that you need to take in order to have Spark in your machines. So how you will be able to install Java and set the environment variables? So I have mentioned this particular link, like from where you will be able to download the Java. Okay, and once you download Java, then it will be the exe file, and you need to proceed for just download and installing that particular file. Now it will take like a couple of minutes in order to have a Java in your machines, and then you will be able to have one. Okay, after let me explain it with the help of presentation. Okay, so once you install, then you need to set the environment variables for Java. You need to set Java home. Okay, so wherever you have kept the Java, you just need to mention that particular path as Java home. Okay, over here inside this, you need to provide the path for bin. Okay, if you are going to mention the complete path over here inside the variable value, then it is fine, it will work. Otherwise, what you can do, you can edit the environment variables and you can provide the bin path over here. Like Java home that you set over here, you can take this variable from here and then backward slash bin you can mention, it will be routed to that particular path. This will be the Java home for your machine. Then Python, the same stuff what you need to do for Python as well. And from this particular, you can download the Python from this particular path, http python.org and downloads. So you can have Python 2.7 plus onwards. Okay, like you need to have 2.7 or higher version for Python. Once you are going to download the Python, then you need to set the environment variables as well, and you can verify it from the command prompt, like user hp python. So Python is like it is going to provide me the list like which Python has been installed. Same fashion, in the same way you can do it for the Java as well, like Java, Java C, and Java version. These are the commands to check the Java is installed or which version of the Java is installed in your machines. Okay, then Spark. So this is the path in order to download the Spark. And once you are going to download the Spark, then you need to keep this particular file in your machine, and then you need to set the environment variables. Spark home, that is nothing but Spark home with respect to that particular downloaded file. And it is in the same way like what you have done with respect to Java and Python. So let me show you over here what I'm having softwares. Inside software, what I'm having Spark 3.4.0. So this is the downloaded file, and what I need to do, I need to set this particular path as environment variable. Over here, the same path, big data factory software and Spark 3.3.0, and you can set it as a Spark home. And once you are going to set it Spark home, then like Spark will be available. You will be able to execute the Spark. So before running this particular command, you just need to proceed with these particular steps in order to have Spark in your machines. Okay, so if it is installed successfully, then you will be able to see say Spark, this particular version is available in your machine. Okay, we are having certain other things we will be discussing on that. Okay, after this, once you are having Spark in your machine, then what you can do, you need to download WinUtils for Windows 64-bit. Your You need to check like which Windows, probably like at this moment 32-bit window is not available. Okay, that is rarely available. So you need to download the WinUtils file for your Spark. Okay, so the link is mentioned over here, and you just need to download the WinUtils files with respect to the version for Spark that you have installed. Okay, so over here, once you are going to download the WinUtils file, so WinUtils files you need to keep in your machine. You need to create a directory. Because focus over here, you need to create a directory. In that particular directory, you need to create a bin, and in bin you need to place these particular file WinUtils that you will be able to download from here, and Hadoop DLL file that you will be able to download from this particular path. So both of these two files you need to keep in your C drive, and you need to create a directory Hadoop. Inside Hadoop bin is there. So once you are having this particular path, then you need to set the Hadoop home for this. So environment variable Hadoop home, it is available as C Hadoop, and then bin is given over here. Because like we are going to refer the bin, so bin is given over here inside the edit environment variables. Okay, so that you need to do in order to have Spark. Now with the help of this, you will be able to have the execution of your code onto the Spark shell. Over here, you will be able to type the code, and or you will be able to copy and paste the code. But what you need to do, you need to have a IDE as well, that is integrated development environment, in order to write down the code. So you just need to install PyCharm ID, or you can have any another ID as well. So in PyCharm ID, this is the way how to install PyCharm. So this is the path. From there you can download PyCharm for community edition. No, don't proceed for the professional, because it will be valid for 3 months, 30 days only, and after 30 days it will ask for the payments. So proceed for the community edition, and once you are going to have once you are going to download and install that particular ID, then you need to proceed for the project creation. So you once you open it, it will ask like proceed for the creation of project, give a project name and path, and then click on to the create. The project will be created for you, and then you will be able to type the Python code. Okay, certain settings you need to do, but first you just need to have the installation up to this particular step, and then I will tell you how to to do those particular settings. So we need to set certain settings and all. I have mentioned these particular things inside the presentation, but I will guide you in order to do those particular settings. Not an issue. Just have the PyCharm ID and verify the installation like Java, Python, and PySpark installation in your machine. Once that is done, then we will be able to write down the PySpark code. I will share this presentation. No need to worry. Fine so far?
Ashok, how we are getting those environmental variables, that window from where we are getting?
Okay, so you just need to type environment variables. Okay,
Okay, okay, okay.
env, it will open environment variables, and you need to set system variables. You need to set system variables. So over here, just click onto the new, okay, and give the name, say Hadoop home. Okay, okay, and over here you just need to mention the value, say the Hadoop is available in C colon Hadoop. Okay, okay, this is the Hadoop form, and once you are going to set this, so you just need to refer the bin directory. If you are going to mention bin, then it will work. Otherwise, what you can do, you just need to click onto the Hadoop home, see Hadoop, that is nothing. So over here, you just need to click onto the edit. Oh, sorry. Once you are going to have this, then
Just twice click on this C Hadoop, na mouse. No, 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 no. In the Hadoop home,
just a minute,
just
just a minute, just a
click
minute.
on the mouse twice.
That is fine. No, it should open edit environment variables. Huh? With this edit, it should come. Mhm. Just a minute. Huh? Mm, just a minute.
Ashok, click on
Mm-hmm.
the path. Go cancel that one. And here na program file window system, yeah, PS module path, I think.
Ha, 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 ha,
Yeah,
ha.
then the window will come.
Okay, so in this particular path, we are having all the variables. Huh? Okay,
Yeah.
so in this over here, you just need to like type say new, and you just need to mention say percentage, say Hadoop Hadoop home percentage, and then say Bina. Okay, so that's it. Huh? So it will refer that particular variable. Huh? Let me delete this. Okay, so this is the way like how you will be able to set. So path is having all the environment variables. Whatever we have set, it is having all the variables. Java home, Spark home. We have defined it over here. You can set the complete path, okay, or you can provide the path with respect to a variable over here. Like the absolute path. Okay, so you can provide the absolute path over here, or you can provide like the partial path with respect to Hadoop home, and then provide the bin directory over here. Okay, percentage Java and oblique home underscore home, that is nothing but the Java home variable which we have set, and it need to refer the bin directory. Okay, so this is the way like in order to set the environment variables. Right, right.
Okay, sure.
Right, Ashok.
Perfect. So, what I was saying, once you will be having PySpark in your machine, then you will be able to write down, or you will be able to create RDDs or data frames. Huh? Okay, so just have a look. Now, inside this particular machine, let me create a test. Test text. And let me type something over here. Hello, how are you? Welcome to Big Data World. Okay, and let me save this. Okay, so what I have mentioned over here, RDD is nothing but in memory distributed collection of element, and it can be created with different methods. Method one is while reading the data. Okay, once we are going to read the data, then we will be able to create the RD. Okay, now where we are going to create the RD? Inside the Spark shell or IDE. IDE, that is nothing but PyCharm, that like we have seen, we will be going to have the discussion onto the IDE as well, but At this moment, we will be going to discuss about the Spark shell. Okay, shell scripting. So over here, once we are typing PySpark, then it is providing me certain information like the PySpark version is 3.4.0. Okay, and I'm having Python version 3.11.4 in my machine, and Spark Web UI is available onto this Web UI, Spark UI basically, where we will be having the information about all the applications. And Spark context is available as SC, and Spark session is available as Spark, and master equal to local, and this is the application ID. Application ID, like for this particular session, whatever the code I'm going to type over here, with respect to that, I'm having this particular application ID. I'm running Spark onto my local machine, so Spark master equal to local is coming. Okay, and then SC and Spark, these are nothing but entry point to the Spark cluster. Okay, if you are going to have the execution of your code, if you want to execute something onto the Spark cluster, then you need to have an entry point. So Spark context and Spark session is nothing but entry point to the Spark cluster. This is the key of the house. Like say you need to enter in a particular house, you need to take the feel of the luxury what that particular house is having. So you need to have the key. Okay, so or entry point, what I can say. So entry point is SC, that is nothing but Spark context, and Spark session is as Spark. So once we are working with RDDs, then Spark context is the entry point. And once we are working with data frames and data Spark SQL data set, what I can say, once we are talking about Scala, inside Scala, we are having data sets as well. So Spark session is required. So let me mention over here. Spark context and Spark session are nothing but the entry point to Spark cluster. If we need to have the execution with Spark cluster, then we need to have this entry point. Without Spark context or Spark session, we will not be able to execute our code. Okay, it is not possible to work with Spark without Spark context and Spark session. So method one, that is while reading the data. Okay, so we are having say a particular file. It is placed onto this particular path. Okay, let me copy this path. Yes, please.
चाय बनाई इसलिए दे रही हूँ चाय दे दो अभी ये बात मैं खा लूंगा तो हाल सुनते ही पहले सुनते सुनते पेट भरा है मेरा फ्रेश होने
गौरव म्यूट कर ले, गौरव म्यूट कर ले।
ये रख दो मेरा
अरे जबरदस्ती खिला रहे हैं, एक तो खा नहीं रहा है।
ध्यान भंग नहीं होना चाहिए।
सॉरी है।
Okay, not an issue. Okay, so what I have mentioned, in order to write down the code in Spark, we need to have the entry point. Okay, entry point in terms of Spark context and Spark session. So we are having this particular file that is test. So let me keep it over here. Let me keep it over here. Test. Actually, like 3 dot PySpark, it will not be taken. It will throw certain errors once we are going to read this particular file. So to have a correct path, I have pasted this particular file over here, so that we will not be having any issue. Okay, from the learning perspective, one dot big data, I have used space, dot, and hyphens. So it will not be good once I'm going to mention these particular things in a path. So it can throw certain challenges. Huh? So over here, what we are having, the path is mentioned in a correct way. So I can utilize this particular path. Huh? So let me use this one. So big data factory, and what I'm having test.txt. Okay, txt. This is the file what I'm having. What I'm having over here. It is having certain content and it is not having a schema as well. Okay, so this is the path. Now what I want to do with the help of this particular file, I want to create an RDD. So say RDD1, or what I can say base RDD. Yeah, this is the initial RDD. So I'm giving a name base RDD, and sc dot spark sc dot say parallelize, and you just need to mention the path. Okay, so sc over here, sc is nothing but spark context. So we have used this particular SC from here only. Like I have mentioned, either I'm going to mention say spark context dot parallelize and mentioning the path of the file, or I can leverage this particular, or I can utilize the SC that is nothing but spark context over here in order to create the RD. Parallelize is a function. Okay, parallelize is a function which is going to sorry, not parallelize, sc.text file I'm going to utilize, sorry, text file now. Okay, sc.text file, that is like this is the text file. So spark context.text file, and this is the path for that particular text file, and with the help of this I will be able to create the RTD, sc.text file now. Okay, now the path over here, it is mentioned in the the Windows way of mentioning the path. So what you can do, either you can mention it in the Linux format, you can mention it in this way, or you can use the double backward slash. Then it will be able to understand this particular path. So let me try to copy this and paste it over here. Okay. Okay, so it has read this particular file. Let me try to base type of base RD. Okay, and based RD. I have used the okay based RD. So this is of RDD type. This is of RDD type. So what I'm planning to say over here. So I have created a based RDD, and how I have created it while reading the data. How I can read the data with the help of this particular function sc.text file. Okay, so parallelize, I have used the keyword parallelize. So if you are having a collection and if you are going to create a particular RD on top of that particular collection, so over here we are having a collection that is nothing but a list. Okay, with the help of this I'm going to create the RD. Okay, so data is this one. Let me try to paste it over here. Okay, this is this one only. Control C. Okay, now type of list, type of data. So data is of list type. Okay, data is of list type. This is a list. The issue with this particular list is it is available to a single node only. But if I want to distribute it among multiple machines, then what I can do, I can create a RDD on top of this. So RDD1 equal to sc.parallelize, and let me try to check the type of RDD1. Okay, so this is of RDD type. Okay, this is of RDD type. Now, what I can say, method 2 is nothing but RDD creation once we distribute collections element, collection elements. So data is nothing but a collection list available over here. And now what we have done, we have distributed this particular collection onto different machines, so it will create a RDD. Method 2, RDD creation once we distribute the collection element. And how we will be able to do that? With the help of dot parallelize function. Dot parallelize function is utilized for the collections, and if we are willing to read something uh, with the help of a particular file, or if we are willing to read something from a particular file, then sc.text file clause can be utilized. Let me try to collect. So based rdd.collect. Okay, just have a look. So hello, how are you? Welcome to Big Data World. Okay, so this is nothing but the data what we are having in this particular based RDD. Okay, so base RDD.collect, we are able to get the outcome with respect to what is available in this particular file now, and this is the content of this particular file now. Okay, so
Ashok,
test is
sorry,
having
I'm audible, Ashok?
sure.
Yeah, Ashok, I'm not able to get the function of this RDD. Basically, why we are creating, what is the role of RDD? Can you please mm, elaborate more on that because I'm not able to get that.
Okay, you can take it in this particular way, like you are having certain data in a particular file, that is not the structured one. Okay, that is not
Okay,
a structured
okay.
data. Now
Mm-hmm.
you need to process that particular data. So first of all, you need to read that particular data. So what we have done over
Right.
here, we have read it with the from a given file, and
Mm.
once we are going to read the data, then it is going to create RDD. Okay,
What
now
is
you will
RDD
be
basically?
RDD is nothing but distributed collection of elements. This particular file is distributed among different machines at this moment.
Okay, so we are trying to read that distributed data from all other machines, right?
You have gone through with Hadoop.
Mm-hmm.
Okay, you are having the understanding about MapReduce, right?
Right.
So MapReduce is doing what? Distributing the data among different machines,
Mm-hmm.
right? So same thing is done with the help of this particular line. So we are having this particular file. Okay, now what we are doing, we are going to process this particular file. So in order to process, at least the first thing what it will be there, we need to read it. So
Right.
we have read with the help of sc.text file clause. Now what I
Okay.
can do, I can write down the code to calculate the frequency and all, right?
Okay. 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 Fine.
Okay, I can split this particular data, then I can apply certain actions, transformations in order to get the outcome. We will be having discussion onto those particular things as well, but at least the first step what it will be, we need to have the understanding how we will be able to create RDD. We know what is RDD, but how we will be able to create RDD? So three methods are there. We have gone through with two methods in order to create RDD. Like once we are reading the data from a particular file, then it is going to create an RDD. Once we
So
are once we are having a collection, and collection is available on a single machine only, but if you want to have the benefit of distributed computing, we want to distribute that particular collection onto different machines, then we can utilize this particular keyword parallelize. So parallelize is going to distribute this particular collection into the different machines, right? Fine so far?
Right,
Right,
Ishant,
right,
right.
Ashok.
Perfect. Huh?
So
Okay.
we can say that RDD is type of a data structure like in other language. In pandas, we are having data frame. Here we also data frame where we can put data like in
You
SQL we
can
can put data in table format. In pandas we can in data frame we can put tabular data in data frame format. Here we can put the data
we
in
can
RDD
say, we
format.
can say, we can say.
Because every language supporting its data structure where how we put the data into which form.
Come again?
In every language we have a structure data structure where we can put data in the defined form. Like in pandas we can put tabular data in data frame.
Hmm.
In SQL we can put data in tab tables, or in
Hmm.
Hive we can put data in tables. Same in this RDD in Spark PySpark we can put unstructured data in RDD format, unstructured data in
Yes.
data frames.
We can say. Okay. So same what I have mentioned over here. Okay. If you are having batch data with no proper schema, then you can refer RD. In the starting of the session itself, I have gone through with these particular basics, right?
Yes, understood.
Okay. Huh. So we are able to read the data, and once we are reading the data, it is providing me a RD. Once I'm going to convert the collection into RD, then it will be distributed among different machines. So that is the method 2. Now the third method, that is nothing but once we apply a transformation. Once we apply a transformation on a RD, then on a RD, then it will provide another RD. Okay, another RD. So method 3, it is saying, say, once we apply a transformation. So once we are talking about operations in PySpark or
As-
operations on RDs, or
Ashok,
operations on PySpark,
hello,
what I can say.
hello,
Yes,
hello.
yes, yes, yes.
Before
Mhm.
going to the third method, so just want to confirm method one. Okay, so in method one, can we do the parallelism or not?
No, 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 no. We can't. We are reading from the text file.
Uh, okay,
We are
okay,
reading from
yeah,
the text file. So we need
uh,
to use the function for text file.
okay. For in our local machine, we can say, and we can read only, right? In a single machine only. Hello.
So don't bother about the single machine and all. Okay.
Uh,
So from the learning perspective, it is providing me the cluster. Okay, one node cluster, and over here inside the Spark, like we are having different level of parallelism. So say first one is node level. Say we are having multiple worker node, worker node, worker node, worker node, worker node, worker node. Then each and every node is having certain configuration, and what we will be having executors. Executor
Mhm.
1, executor 2, executor 3. Okay, executor 3. Okay, onto the executor itself, what we are having? We are having cores. Core 1, core 2, core 3. Okay, so different level of parallelism is there, what I have explained. Say if a task is there,
Mhm.
so if a task is there, or if an application is there, okay, if an application is there, so first this application is divided into these particular nodes. Okay, worker nodes basically. Okay, worker node is having say executor. Say if like I have taken 3 executors, if I have taken say 12 executors for running this particular application. So 3 executor it has given from here, 3 over here, 3 over here, 3 over here. So I will be getting the 12 executor. In 12 executor, I'm having the different core. Okay. So say this first executor is having 3 cores. So what I will be able to have, say partition 1 is given to this, partition 1, then partition 2, partition 3. Okay, partition 2, partition 3. Okay, if this is the case, like executing this particular application, so 3 executor per machine, 3 executor per machine, we are having 4 machines, and then 3 core per executor is there. So then at that moment, what I can say, 3 4 is 12, and 12 3 is 36. 36 partitions will be executing in parallel in this particular cluster.
Mhm.
36 partitions will be executing in parallel. So suppose you are having one node cluster only, one node cluster only. So this particular mechanism will be there for you, friends. Okay, you will be having, say, you can have 3 executors, you can have 3 cores, or you can have 2 executors, 2 executor, 1 core each, given to the partition. So it is not
So,
like say,
so
please
one,
ask.
yeah, so one question here, like, suppose if we are going to worker node one, okay,
Hmm.
so like how many executor the particular node is supported, so we can decide on self, or is there any
Yes, we
limitation
need
on
to
that?
decide. We need to decide. It can be decided.
Means
How it
like,
can be decided? We are having the configuration of each and every node. We are having the information. Say, worker
like
node is having say
content types.
16 core, 16
Uh-huh.
core, and 512 GB of RAM. GB of RAM. Okay. So what I can do, say, if I'm going to create say 4 executor, say 4 executor, 4 core each, 4 core each, and then 4 1 ja 1 128. So 4 core plus 128 GB of the RAM will be there for each executor, right?
Mm,
So I will be having four
got,
executor.
got
Okay,
it, got it.
then one executor is having 4 core. Then further it can be divided, say, like it is going to take say one partition at this moment and divide by 4. So what I can say, 32 GB of the RAM, 1 core, 32 GB RAM. It will be given to one partition. At the like in this particular way, like the parallelism is working in Spark. Okay,
Okay.
so
Okay.
it is not like say the data we are having only single node cluster and we will not be able to get the benefit. Certain benefit will be there, not an issue. Okay, but this is good for the learning perspective only. Yeah, learning perspective, like the Spark and Hadoop kind of methodologies are or framework are developed in order to deal with big data, huge amount of data. If we are having less data and we are leveraging a huge cluster, then it is not going to provide a good gain. Even like this, cluster spinning time is more over here once we are talking about Spark. So Spark, once we are going to initiate the Spark program, it is going to take initial 30 to 40 seconds because it is analytics framework, not the transactional one. If you are looking for the transactional solution, then there are different, you can say, modules, what I can say. You need to proceed with SQL like mechanism, right? Fine so far?
Yeah, so
Perfect. So what I have mentioned, there are three methods in order to create the RD. First one is while reading the data from a text file or from a particular file. Second one is once we are going to distribute the collection among different nodes. Okay. Third one is once we are going to apply a transformation. So once we are talking about Spark, then there are two types of operations. Two types of operations are there, and two types of operations are nothing but transformation, transformation, and second one is action, transformation and action. So once we apply transformation, then nothing will happen in Spark. Okay, what it will do, it will not this particular operation, or it will maintain a DAG. It will maintain a DAG. Okay, so what is the meaning of this? So if you are having a particular RD, and on that particular RD, if you are going to apply a transformation, then nothing will happen. Okay, say you are having RD1. Okay, onto this, what you have done, you have applied a transformation. Let me mention it with T. Then RD2 is there. Then on RD2, what you have done, you have again applied for the transformation. Then you got RD3. Okay, on this RD3, then you have applied a transformation. Okay, and RD4 is there. Okay, RD4 is there. On this particular RD, you have applied an action, then the execution will begin from the beginning. Okay, execution will begin from the beginning, and it is maintained in the DAG. So DAG is nothing but directed acyclic graph. Okay, whatever the operations we are going to perform on a particular RD, it is going to maintain the entries onto the DAG. And once we are going to take the action, then with respect to the DAG, like the execution will begin from the starting, and then at the end we are able to get the outcome. Okay, so transformation, what is the meaning of transformation? Say you are splitting the data, you are filtering the data. Okay, you are performing certain transformations like reduce by key, group by key, sorting data. Okay, so those are nothing but transformations. These are operations only. So once you are going to perform transformations, then transformation is not going to perform, nothing is happening onto the RDD, but it is going to maintain the entry inside the DAG. And once we are going to take the action, then the actual execution will begin and we will be able to get the outcome. RDD's transformation will not provide any output. Okay, so over here, just have a look. Say if we are having this particular, we have done what? We have based already sc.text file and we have mentioned the path and type of this. Okay, type of this is nothing, and like we have not got anything. Let me try to execute it once again. Okay, so based already, and what we have done, we have read the file. Are we able to get what we have read? Until unless we are not performing any action over here, nothing will happen. Okay, nothing will happen because Spark is lazy in nature. Spark is lazy in nature. Spark is having lazy evaluation. Spark is having lazy evaluation. So transformations are going to update the DAG only. Okay, nothing will happen. And once we are going to take an action, okay, then actual execution will begin. Once we are applying an action, then actual execution will begin from starting, and then we will be able to get the output. Okay, so just have a look over here. Okay, so this is the Spark official website, and over here we are having RDDs, accumulator and broadcast, and what I'm trying to show, that is action and transformation. Okay, so these are the transformations: a map, filter, flat map, map partition, window index, sample, union, intersection. Okay, distinct, group by key, short by key, co-group, Cartesian, pipe, coalesce. Okay, these are nothing but transformations. Repartition, and short window partition, short within partition. These are nothing but transformations what we are having inside the PySpark, and these particular transformations are not going to provide me any output until unless the action is taken. Once we are going to take the action, then the execution will begin from the starting, and based upon the applied transformation, it is have the computation on top of the data, and then we will be able to get the output. And what are the different actions? Reduce, collect, count, first, take sample, and these are nothing but save as sequence file, save as object file, count by key for each. These are nothing but actions. So over here, what I have done, I have applied the transformation. Let me try to apply a transformation. What I want to do, so once I have read this particular file, so it has provided me, just a minute, I'm getting a call. Okay. So what I have mentioned, like we have read this particular data and it has given me a RDD. Now what I'm trying to do, I'm going to apply a transformation on top of this particular data. Okay, so I'm having this particular data and that is having this particular content. Now I want to split this particular data based upon the space. Okay, I want to split. I just want to have uh, different keywords. I don't. I just want to have. This is, you can say. Uh, I just want to have like array of objects, array of words, what I can say. Now, what I'm having array of line, I just want to have array of words. Okay, I just want to split these particular words based upon the the space. So what I can do, I can I can have a transformation. So based RDD onto the base RDD, what we are having over here onto the base RD, what I will do, I will apply a transformation that is nothing but flat map, flat map. And what I'm going to say, if I'm passing x lambda, if I'm passing x, then it need to provide me what? It need to provide me, if I'm passing x, so it can provide me x dot split. Okay, and split based upon what? Split based upon the space. Okay, array of words, that is fine. So flat map is a transformation. What this particular transformation is doing, say if I'm having this particular line, say hello, how are you? If I'm having hello, how are you? So initially it is given in this particular way. Okay, so we are having this particular line. Okay, this is what I can say, array of string, what I can say, or array of line, that is the same thing. So this is array of string and I want to have array of words. So flat map transformation, what this particular transformation is doing, it is providing one to many relationship. One to many, one to many. Okay, one to many, what is the meaning of this? uh, like it will take single input and it will provide multiple output. Multiple, like say if we are having one index over here, so we will be getting multiple index. So say hello, it will provide me the outcome in this particular way. Hello, it will split it based upon the space and I will be having array of words. Okay, splitting based upon space. Okay. Okay, so in this particular way, flat map is going to take a single input and provide me the outcome. Okay, x dot splitted and it will be based upon splitted based upon the space.
What
Okay,
what
one
is
to
it? What is
many.
X? What is X here?
X is this one. This
Which
entire
one?
you can say is x. Hello, how are
Okay.
you is nothing but
Okay.
x.
Okay. Okay. Okay.
Okay,
Okay.
so I'm taking x and I'm splitting x based upon the space. Right? So if it is having space, it will split this particular x, right? So based RDD, and what I can say, I can store it in say flatted RDD, flatted RDD. Okay, so I have applied this transformation onto this particular RDD. Okay, let me try to copy and paste it over here. Okay, Okay, okay. So this bracket need to be closed. Huh? Okay.
Acha, so okay.
So,
Yeah,
mm-hmm.
why we are giving the flatted RDD here? The rest concept is
It's a
fine.
name. You can give any name. Okay, it's a
Uh,
name. Okay, like
oh,
my second RD. It's a
uh-huh.
naming convention, right?
Okay.
Like
Mm-hmm.
I have applied flat map transformation. That's why like I have given this name. So I'm not good in giving names. So if you are having a better name, you can utilize that particular name. So
Mm-hmm.
flatted RD. And we have read the data. We have applied the flat map transformation. Do we get anything over here?
No,
Do we get anything?
no,
Nothing is there. Until and unless we are not taking any action over here, nothing will happen. Spark is lazy in nature. That's why like Spark is because Spark is lazy in nature, it is going to take the transformations and store these particular transformations inside the DAG. Until and unless we are not taking any action, then nothing will happen. Okay, now if I'm going to take an action over here, then it will start the execution and we will be able to get the output. So let me mention, say, flatted RD dot collect. Collect is nothing but an action. Okay, and now the execution will be started. Stage 1, stage 2, and just have a look. Hello, how are you? Welcome to big data world. This is what we were expecting, right? Initially we were having this, and now we are getting the outcome in this particular way. Okay, fine so far.
mm. Oh, yeah, so fine.
Yes, yes, Ashok.
Perfect. So transformations are going to provide me another RD. The topic is how to create an RD, and the third method was once we are applying a applying transformation onto RD, then it is going to provide me another RD. Okay, so if I have applied this particular transformation, flat map transformation, onto based RDD. Base RDD is nothing but initial RDD. If I have applied a transformation onto this, it has given me another RDD. Okay, RDDs are lazy in nature. What we have seen, Spark is lazy in nature. Properties, properties of RDDs. Okay, uh, RDDs are, just a minute. So what we are discussing, properties of RDs.
Acha, so okay. Hello.
Mm-hmm. Mm-hmm.
Uh, After reading the file, we can go for the transfer method third. Okay. So, is there
Uh-huh.
any possibility can we apply on the method two and we can go for the transformation on the list?
Yes, 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 yes. You can apply the transformations onto the method 2 as well.
Uh-huh.
Okay.
Okay.
Okay, so what we have discussed so far, what is RDD? RDD is nothing but in-memory distributed collection of elements. And then what we have seen how to create RDD. Okay, so whatever we have discussed, properties will come from that particular discussion only. Yeah. Okay, so first one is immutable. Immutable. What is the meaning of immutable?
Once created,
Mm,
can't be changed.
cannot be changed.
Once created, then it can't be changed. Can't be changed. Okay. So over here, I was expecting this particular query from all of you. Say we were having this particular RD, that is based RD, and we have applied this particular transformation, flat map transformation on based RD, and then we got another RD. Okay, so we got another RD. So the way what I can do, like I can have, I can apply the transformation onto this particular RDD itself, and then we will be able to get. Okay, but why I'm saying say, or in another words, say I'm having this particular data. Let me take it in this particular way. Say I'm having, I'm having say, let me take it in this way. Say I'm having initially RD that is having say 100 records. Then I have applied, I have done the filtration, and then I'm having say RD say 2 that is having say 40 records. 40 records. Then I have what I can do. Then RD3 is there. So RD3. Let me take it in this way. Transformation, transformation. Okay, and then action. Okay, so what we are going to discuss immutability. Yeah. So if RTD is defined, then it can't be changed. If we are having an RD, if once it is defined, then it can't be changed. What is the meaning of this? Spark is lazy in nature. We know it very well. Spark is lazy in nature. Lazy evaluation is there. Now, if like we are able to update the records in a particular RD, then the lazy evaluation property will not work properly. Okay, so what is the meaning of this? Say RD initially say we were having 100 records or 1000 records are there. Okay, then 400 are there, then we have applied certain operations, say 500 are there, and again we have done certain filtration and all, then 350 records are there. You can think in this particular way: initial record, filtration, then joining, and then again filtration. Okay, so that is nothing but some a bunch of transformation you have applied. Now, once you are going to apply this transformation, it has given RDD2. Once you apply the transformation on RDD2, then it has given the RDD3. Okay, now RDD3 is say having 400 records. Huh? RDD3 is having 400 records, and 400 records that is given by this particular transformations. Now you are going to add certain records over here, and it can increase to say 500, 600. Huh? You are able to uh, make it mutable, huh? Or in order to have the mutability, you will be able to change the records. If the records are changed, okay, once the action is taken, then you will not be able to get the expected outcome, right? You will not be able to get the expected outcome. In order to have the laziness, in order to work with laziness property in a correct way, and then what I can say, you need to make the RDD immutable. It will not be impacted because of any change. However, if you can apply an operation on an RDD and create another RDD, what you can do, if you really need to have that particular transformation on RDD3 to have the addition of record, what you can do, you can have another transformation over here, okay, on RDD3, and you can proceed with another pipeline, or you can add this particular stuff in this particular pipeline only, so that that particular you can say addition of the records can be accumulated. Are you able to understand?
So can you repeat one more time after the RSD3, after adding the record and all?
Okay, so say RDD3 is there. What I have mentioned, you are not able to change the content of a particular RDD because these are immutable. However, if a particular operation is really important, then what you can do, you can add that particular step in between, okay, and proceed with the operations. What I can say, so you are having this particular transformation, and again you are having transformation. It has given say RDD underscore intermediate, and on RDD intermediate you are going to apply again transformation, and those particular transformation will be providing you the outcome. So you can either add that particular operations and create another RDD, or what you can do, you can create another pipeline. Okay, so say if you are going to have, if you are not able, if you are not going to accommodate this, you can have different pipeline. Okay, pipeline, what is the meaning of pipeline over here? Say you are not going to take this particular operation now, okay, or then you will be having RD6, or say RD6 and RD7, right? Then you are going to to take action over here, take action over here. Okay, are you able to get? Are you able to get?
No, so
Let me repeat it once again. So what I can do, say you are writing the code, already one already say sc dot read the data, sc dot read text file. Just a minute. Let me check who is onto the door. Just give me a minute. Okay, so RD1, RD is there, then you have apply certain say flat map, flat map on this particular RD transformation, then RD2 is there. Okay, then on RD2 what you are going to do, then say filter, you have applied the filtration. Okay, RD3 is there. Okay, then you have applied onto the say map function. I'm taking some transformation RD4. Okay, and if you are going to have RD4 then you are going to apply certain say shorting and all kind of operation, then RD5 and RD5 dot collect dot collect. Okay, so this is say this is the first way. This is this particular way. Say let me take 3, 6 and 7. This is 3, 6 and 7. 3, 6 and 7. This is the this is first you can say pipeline. Now I have used the word pipeline, but you can say this is one piece of code. Second is at this moment you will be getting the output with respect to this particular RDD. Okay, RDD7 dot RDD6 dot collect 6 dot collect. So you are taking an action onto the RD6 and then you will be able to get the output. Second one is second stuff what is there like RD3 is there. Onto RD3 what you have applied certain operation, then you are having RD intermediate. Okay, onto the RD intermediate you have applied another operation. Okay, say shorting, and then what you are having RD4 is there. Okay, let me mention RD4, and on RD4 you have say applied another say function say filter, and then you got RD5 and RD5 dot collect. Okay, RD5 dot collect. So this is nothing but let me remove 3. Okay, so this is a first pipeline, and this is second pipeline what I have mentioned. Okay, so on RDD3 up to RDD3 like things are the same. Okay, RDD3 up to RDD3 the things are the same, but if you are collecting RDD6 then you will be getting the outcome with respect to this piece of code. If you are collecting RDD5 you will be able to get the outcome with respect to this piece of code. Okay, so in this particular way what has happened, the RDDs are not changed. The RDDs are not changed. However, after applying certain transformation, another RDD has been created, and on that particular RDD, we have performed the required you can say operations and got the output. So RDDs is not are over here. RDDs are not changed, but once we are going to apply a transformation, it is going to convert that particular RDD into another RDD. The data which is available onto this RDD3 that will be same over here and over here as well. Okay, but if you are going to apply different operations, then you will be getting the different outcome. You can think in this particular way. Say up to matriculation, each and every student is having all subjects. But after matriculation in like +1 or 11 standard, then some students are going to opt art, then they will be having the subjects or output with respect to that only. Some students are opting medical or non-medical, so the outcome with respect to that only. So it is not like say we have changed the RD. Okay, we have applied a operation, and that particular operation has given me another RD. Is it fine at this moment?
Mm.
Fine, Ashok.
Yes.
Yes, Ashok.
Perfect. So RD once defined, they can't be changed. However, we can apply some operations and create another RD. We can have certain operations on a particular RDD that will create another RDD, and on that RDD we can have the desired, you can say, outcome. But once defined, it can't be changed. That is immutability. Now second one is fault tolerance. Fault tolerance. It is saying once defined, oh, not defined. RDDs are able to heal itself. Heal itself. What is the meaning of this? Say if we are having a particular pipeline, okay, or if we are having certain bunch of operations what we have performed on a particular RD, and in between if a RD is missed, then we will be able to recover that particular RD. Okay, so how that is possible? Okay, so we have this transformation T1, transformation T2, transformation T3, okay, and transformation T4. So we have applied these particular transformation onto these RDD. Say RDD1, once we have applied T1 transformation, it has given RDD2. Once we have applied T2 transformation on RDD2, it has given RDD3. And once we have applied T3 transformation, then we got RDD6. And once we apply transformation 4 onto RDD6, then we got RDD7 now. Okay, that is perfectly fine. Now what we are able to see over here, master, or you can say parent and child relationship is there. So initial RDD, that is nothing but the master RDD. Okay, and for this particular RDD, the RDD2 is the child RDD. Over here parent and child relationship is there. This is the parent for RDD2, and RDD2 is the parent for RDD3. RDD3 is the parent of RDD6, and RDD7 is the parent of RDD. RDD7, RDD6 is the parent of RDD7. Now, because of certain issue, if this particular RDD is lost, okay, lost. So what we are having, we have maintained the DAG, that is directed acyclic graph, okay, which is going to maintain all the entries that these particular operations we need to perform on the RD, and then we will be having another RT. So this DAG is having the information that if we are going to apply T1 transformation on RDD, then it is going to give me RDD2. If RDD3 is lost, DAG is having the information that we need to perform T2 transformation on RDD2, then we will be able to get the RDD3. Okay, so we will be able to get the RDD3. So in this particular way, what I can say, it is fault tolerant, and it is possible because RDs are immutable in nature. If it is immutable, say if we are able to change the value of RDD2, then do we get RDD3? No, we will not be able to get RDD3. Okay, so immutability functionality or feature has added fault tolerance as well inside the RDDs. So fault tolerant RDDs are fault tolerant because they are able to heal itself. Right? Clear?
Yes, Ashok.
Now you need to tell me if RDD, the initial RDD is lost, then what will happen?
All will be lost.
All will be
If
lost.
parent, if yeah, if
Tag will
parent
help.
is,
I think
I think
data is loaded in tag.
no,
We
no.
need to read the data once again and all. Huh? So
Okay.
these are like
Tag
certain
will not help.
things. Those particular things should come in your mind. Huh?
Tag is a process. What is tag actually? This is
DAG is a graph basically. Huh? Okay. So flow chart you can say. Huh? So say what it is saying. Say we are having initial RD, yeah, onto this, what I'm going to do, I'm going to perform this operation, then I'm able to get this one. Okay, on this one I'm going to perform this. So this is nothing but a flow chart, which is having sequential steps in order to have the execution on a particular data. Graph, directed acyclic graph, right? Fine. Lazy evaluation, you know it. This is the Spark functionality. Lazy evaluation.
it Spark or
Then
RDD? It's
RDs.
happened in data frame as well.
These are, you can say, evaluated lazily. Yeah. Okay.
Okay.
Once we are going to define RDs.
No, no,
Okay.
no. My question is that it is happen in data frame as well or in RDD only? Lazy evaluation.
I'm not here able to hear properly.
Lazy evaluation happened in data frame or it's only property of its RDD?
Data prep. I
Data
didn't get
frame,
it.
data frame,
It is.
Gaurav,
It is universal. It is universal.
universal.
I think data frame is not lazy evaluation. Na? In data
Uh,
frame, we can use in place. So every time we need, no need to assign it to a new data frame.
No, we are going to like read the data, okay, and the processing internally is done with the help of lazy evaluation and all, right? Over there as well, we are having actions and transformations, right? Lazy evaluation is with respect to action and transformation, right?
Okay.
So say if we are having dot count, say count is the action, so rdd dot count is there and df dot count is there, okay. So once we are using df dot count, that is data frame dot count, so the execution will begin, if we are just mentioning the transformation, say df dot reduce by key, that is nothing but transformation, reduce by key. So nothing will happen, nothing will happen. It is going to take this entry inside the DAG. So that is with respect to lazy evaluation is with respect to actions and transformations. Actions and transformations are available into both of these two, two components. Right?
Right. Right, Ashok.
Right, Pankaj?
Yes, yes, Ashok.
Okay. I think it's fine for the day. And tomorrow we will be having like more discussion onto the RDs. We will be going to have certain programs onto RDs. Okay, the very first program that we are going to execute tomorrow, that will be the word count program, word frequency calculator, and after that we will be having certain other programs as well. So what you need to do today, you need to have Spark in your machines. Okay, and once you are having Spark, then we will be able to have the execution. Okay, so
Uh,
that's it for this particular session.
so please share the
Someone,
PPT, installation
yeah, I
PPT,
will share the PPT. Yeah, just a
and
minute.
the TXT file as well.
Okay, sorry guys. So that's it for this particular session. I will share the presentation and the notepad file. Try to do the practice and see you tomorrow. Thank you.
Okay. Thanks,
Yeah,
Ashok.
thanks, Asoka.